All right, let's talk a little bit about lightning safety. Now, one of the most well-known devices for lightning safety is the lightning rod. Now, here's the common understanding of a lightning rod. In fact, this is what the lightning rod was originally invented to do. Um, the basic idea of a lightning rod is that any positive charges, instead of building up in the house, are built up in the top of this lightning rod. So when lightning does come and strike, it strikes the lightning rod itself, and then you have an insulated wire that goes down into the ground, allows the charge to flow into the ground, and you're safe. The charges dissipate, and your house is protected. Not completely. This does cause a lot of radiation, electromagnetic waves, microwaves that are too intense, induce currents within the house, and they can short out appliances. They can trip circuit breakers. They can do a lot of things. Yeah, that's better than lightning striking the house itself, setting the house on fire. Um, but this can still cause a lot of damage. But it does, for the most part, protect the house. However, oh, by the way, hopefully you know who it was that came up with the idea of a lightning rod. It was a great physicist in the late 1700s who did a lot of experiments with electricity. His name was Benjamin Franklin. Benjamin Franklin was a physicist, did a lot of experiments with electricity. He's actually the one that came up with the notation of positive and negative charges. But anyway, he's also the one who came up with the idea of the lightning rod. But since Benjamin Franklin, we've learned more about electricity, and we found that there's something else that a lightning rod can do. We talked about it in our last video. Remember when we talked about St. Elmo's fire, where you have a narrow tip? Um, when you have a narrow tip, charges come up to this tip, and the charges can more easily come off of that tip, and then the charges are released out into the air um, harmlessly, thus decreasing the total charge on um, decreasing the total charge of the building itself. If you were to actually go up to the top of many tall buildings, for example, if you go on campus and were to go on top of the nursing building, building 320 on our campus, what you would see is that the entire building has a lot of these cables and pipes and all sorts of stuff. What it's doing is it's taking all of that charge, the charge is built up in a building during a thunderstorm, and directing it to this whole system. And these are connected to some spikes that are found all the way around the building. Those spikes aren't meant to attract lightning, but they take all that charge that's built up in the building, come up here, and those charges are allowed to escape into the air, thus decreasing the total charge of the building itself. And so that helps to decrease the chance that a large building like that would be susceptible to being struck by lightning. The next time you're around a tall building, look to see if you can see a number of these spikes around the outside edge of the building. That's what they are there for. It's a much easier, much safer way than trying to attract the lightning to a lightning rod. It's a much safer way to protect a building. All right, another safety tip here. When lightning strikes a car, lightning is going to hit the car, go around the car, and into the ground. Whenever you have a uh, metal frame such as a car or a shed or an airplane, the lightning's current is going to go around that object, take that metal path around whatever's inside, then go safely out the other side. Do a Google search for airplanes struck by lightning. It happens all the time. Lots of airplanes get struck by lightning without any damage. Why? Because lightning goes around the frame and out the other side. In the case of a car, through the frame into the ground. You can actually see here in this picture where the car was struck by lightning. These areas here would be where the tires were sitting and that particular car was struck by lightning. Okay, let me add another note here just to make this point. Your car, let's say you're driving along and your car is struck by lightning and your car dies. It's not going to go anywhere because it's overloaded from the electric shock. But you'll be perfectly safe inside the car. So lightning strike happens, storm dissipates a bit. You decide to get out of the car. Don't. Because there is still some residual charge inside the car's frame. So if a car is struck by lightning, there will still be some charge in the frame. Remember that rubber is a good insulator. Not perfect with the amount of electricity in a lightning strike. There's no way that tiny amount of rubber on the tires will insulate the car completely. But there is a little bit of insulation, which means that some charge will stay inside the car. Well, the moment that you step out of the car and touch the ground, that current is then going to flow from the car through you into the ground. No, not a good idea. So the best thing and safest thing to do when your car is struck by lightning is stay in your car and wait for help. If your phone works still, which hopefully it does, you can call for some help. Some roadside assistance people will come and discharge your car so that you can safely get out of the car. All right, scenario number 2, you're in a car, get struck by lightning, your car catches fire. You cannot stay in that car. That would be suicide. You have to get out, but you don't want to touch the ground because you will complete the circuit. Charge will flow from the car through you into the ground. So how do you get out of the car? What you do is you open the door, you stand on the little step on the edge of the car, and then you jump as far away from the car as you possibly can. And you just stay, you never touch the car and the ground at the same time. So there's a little bit of a tip if you're ever in a car that gets struck by lightning. And yes, I have had students who were in cars that were struck by lightning, so it does happen. Okay, another scenario. Let's say that you're out in the middle of a field. It's raining cats and dogs. It's raining like crazy. And so you find the closest shelter that you can, a tree. Don't go under an isolated tree. Reason being, remember that lightning loves, that charges go up any surfaces that are, or any objects that are sitting on the ground. Your tree would become charged, which means it would be a target for a lightning strike. If you're in a forest of trees, then you minimize the likelihood that you are of being under the particular tree that gets struck by lightning. So if you are out in the middle of a field, there is no grove of trees nearby. There's just one single isolated tree. You don't want to go under the isolated tree. What do? Don't lie on the ground either. If you lie on the ground, then if lightning strikes in the area, the ground becomes electrically charged. You're connected to the ground. You get zapped. The best thing to do would be squat on your feet. So you're on your feet, you squat down so that your feet are still the only things touching the ground and your height is minimized. Is this ideal? No, you could still get struck by lightning. But if you're out in the middle of a field and there's nothing around but trees, that's safer than anything else. The safest thing to do would be to find a house, a building, or a metal shed. Why? Because the metal shed would do the same thing that a car would do. If you're inside of a metal shed, if it gets struck by lightning, the electricity will go around the building and into the ground. You would be safe. Okay, where does lightning happen the most here in the United States? Well, welcome to the lightning capital of the world, here in Florida. Because of the large number of thunderstorms we have in Florida, we get large numbers of lightning, large amounts of lightning here in Florida. Now, we do have a series of lightning detectors all around the world. In fact, I mentioned earlier in this video the nursing building on Daytona State campus. If you go see the nursing building, you'll see the small spikes around the edge of the building, but you'll see a large pole from the center. That is a lightning detector to help the United States detect where lightning strikes are occurring. This is part of the North American Lightning Detection Network. And Visala is the company that maintains it. That's where this graph comes from. But that's one way of detecting lightning. Another way is using satellites. When lightning strikes, it actually emits an infrared wave, a series of infrared waves. Well, you have satellites in orbit, and those satellites that are in orbit detect, bam, there's an intense burst of infrared radiation coming from this point. We know that lightning struck right there. Oh, there's another burst of infrared from here. Oh, a burst of infrared from here, so on. And so you can get the lightning detection network from satellites. This is great because our lightning detection network on the ground cannot go over water. We don't have any good detectors over water, but satellites can. Satellites can see lightning that occurs over water. By the way, notice something very striking here, the number of lightning strikes that actually happen over water compared to over land. Lightning definitely happens over land much, much more frequently. Each year, lightning causes about 10,000 fires, $50 million worth of damage. That statistic is probably a little old. I would bet that that number has gone up in the last couple of years. So we talk about how can we minimize lightning? Well, we've got lightning rods, we have safety procedures, so on, but lightning is still going to strike and it's going to cause fires and damage. So we've played with the idea of lightning suppression, where you seed clouds with aluminum. What this does is it would dissipate the thunderstorm a little bit faster, plus it would carry the charges within the cloud a little bit easier, thus decreasing the amount of charge built up in a cloud, decreasing the potential for a lightning strike. There are two big problems with it. One, you're dumping aluminum over the whole world, which is not toxic, it's not harmful to the environment, but it's still getting everywhere. Second, that's a large amount of aluminum that we need to mine, file or shape into the right type of aluminum flakes, and then fly up over a thunderstorm to seed a cloud. It's just not an economically feasible method of suppressing lightning. But that is still an ongoing area of research on how to protect homes and businesses and lives by suppressing lightning.